So for example 5.5 on page 201, it's talking about the sample space for a disease called cystic fibrosis. And it talks to us about a gene being dominant recessive and that it's inherited by the parents. And so you have the mother and the father. Well, over on page 202, it helps us with the tree diagram. A lot of times these are very helpful, the tree diagrams are, whenever we're trying to find the sample space. So what you have is, you first have the mother. The mother provides one gene to a child, and that gene can either be dominant, meaning A, or it can be recessive, basically meaning that this child is a carrier. So it's an either-or situation, okay? This is for the mother. Now, if the mother gives a dominant, the father can still give either a dominant or a recessive gene, okay? So that means that if you follow these branches, the child receives a dominant from the mother and a dominant from the father. This is one possibility. The child could also receive a dominant from the mother and a recessive from the father. Another possibility is if the mother gave a recessive, the father can still give a dominant or a recessive. Therefore, they received a recessive from the mother and a dominant from the father. Now, this child right here is not sick because they have two dominant genes. These two children receiving one dominant, one recessive from either parent is what we call a carrier. Now, if you'll notice, this possibility is recessive, meaning that this child has cystic fibrosis. The only time you can have cystic fibrosis is if there is a recessive gene. And so what you do whenever you're looking for these, you're going to follow first the mother's possibilities, which is either a dominant or a recessive, and then the father still has the same possibility no matter what. Can be a dominant or recessive, dominant or recessive. And so you actually have four possibilities. You have both dominant, you have a dominant recessive, you have a recessive dominant, and then you have two recessives. These two look the same, but they're different because these first letters come from the mother, these second letters come from the father. The result is the same, but they're still different possible outcomes. Therefore, there is a 1 out of 4. Here's the 1 out of all 4 of these possibility of having cystic fibrosis. Now, you also asked about whenever you are flipping a coin 3 times. So let's think about flipping a coin 3 times, okay? We have the first flip, we have the second flip, and we have the third flip. Do the same thing with flipping a coin as we did with the dominant recessive. The first coin can be heads or tails. Now, it doesn't matter what happens on the first time. The second coin can also be heads or tails. Notice how I'm drawing a heads and tails off of both of these, because the first option is to get a head or a tail. Well, based off of that option, I still have this other possibility of getting a head or a tail. The same thing is actually going to happen with my third option. I'm going to have the possibility of getting a head or a tail on every single one of these possible outcomes. Because again, they're independent of each other, okay? this one, what happens on the first one does not affect what happens on the second one. So I can still get heads or tails. So if you look at our possible outcomes, we have 3 heads. We have a head, head, and a tail. Head, head, and tail. Or we have a head, tail, head. So this one's a head, tail, head. This possibility right here is a head, tail, tail. This one is going to be a tail, head, head. Then we have the option of a tail, a head, and a tail. We also have the option of a tail, tail, head. Or we have the option of a tail, tail, tail. And it asked for the probability that all 3 are heads. Well, if you look at this, these are all tails. This one has 2 tails and a head. This is the only possibility with all 3 heads. So there's 1 out of 1, 2, 3, 4, 5, 6, 7, 8 chances that can happen. Another way that you can look at this is you're going to flip the coin 3 times. So you have the first time, the second time, and the third time. Well, the possibility of getting a head in this first time is going to be 1/2. Because you either get a head or a tail. The possibility of getting a head in the second time is also 1/2. The possibility of getting a tail in the third time is also 1/2. Since we want this to happen, and this to happen, and this to happen, an and means we're going to multiply. So I'm going to take 1 times 1 times 1, giving me a 1. A 2 times a 2, which is a 4, times another 2 is an 8. I still come up with that 1/8. That's the probability of getting all 3 tails. But I think the biggest problem is getting these sample spaces down over here, because I think this is where we're having the most trouble, is finding these sample spaces. Draw these tree diagrams. It's much easier to do with the tree diagrams. Let me know if you continue to have questions.